Welcome to solverfy.
The magnetic field exerts a torque on the current carrying coil, which causes us to turn. And we can find the whether the coil will rotate about axis A1 or A2 using this formula. So basically, torque is equal to mu cross AB, where mu is given by the magnitude of mu is given by I times A, the current. So for this particular case, mu should point, if the current is clockwise, then mu should point out of the paper, and if current is anti-clockwise, mu should point into the paper. For like whichever the case is, uh, the direction of torque ultimately will be so there will be no torque about A1 because there won't be any because the cross product will just be zero, but there will be a torque about A2 because only the torque is along top and bottom sides of the coil. So yeah, now to find the angular acceleration of the coil, we use Newton's second law, which says the total torque is equal to I times the angular acceleration. So now we know now we know that first we have to find the moment of inertia. So to find that, treat the two 1 meter segments, this and this, as point masses, since all the points in them are 0.25 meter from the rotation axis A2. Now the two 0.5 segments, 5 meter segments, are treat them as thin uniform bars rotated about their centers. So, so this segment and this segment are basically two rods rotating about axis A2, so rotating about their center, and AB and DC are uh, rods, but they can be treated as point masses, uh, which are rotating about the axis A2, that is at a distance of 0.25 meters. So this is this distance. So that's half of this distance. So 2.25 meters. Now we know that since the coil is uniform, the mass of each segment is proportional to its fraction of the total perimeter of the coil. So each 1 meter segment is one third of the total perimeter. So its mass will be, so let's find the total perimeter first. So total perimeter is twice of this plus this. So that's basically 3 meters. So each 1 meter segment will have a mass, then the total mass. So basically one third of the total mass. So so 1 comes from the length of the segment, 3 is the total perimeter. So this much perimeter, this is the total length, contains this much mass. So how much mass will the 1 meter segment will have? That's basically what we are doing right now. So that is equal to 0.7 kg. I have basically done the calculation and converted to kgs. So when you do this exactly, you'll get 70 grams, which you need to convert it into kilograms. Again, the mass of 5 0.5 meter segment will then be 0.5 over 3 times 212, the same process as we did above, and that will be equal to 0.035 kg. So then moment of inertia will be moment of inertia of AB plus moment of inertia of DC. These two will be equal, plus AD plus moment of inertia of CB, and all about axis A2. Now the moment of inertia of AB or CD is equal to 1 over, sorry. So we are treating those as point masses. Yeah, so we are treating these two segments as point masses, so that the moment of inertia will thus just be the mass of this segment times the distance from the axis, which is 0.25 meter. So this will be then equal to the mass. So let me just, okay, so this is actually 0.07. Sorry for the calculation mistake. So we plug those values in here. So moment of inertia is basically mr square, right? So that's what we are doing here. So, okay, let's just leave it like that. And moment of inertia of BA and CB both are equal is 1 over 12 mr square. So that is equal to 1 over 12 times 0.35 kgs times 0.5 meter square. And this is basically moment of inertia of a point mass, which is mr square. So the total moment of inertia will be a sum of all of these. So 2 times this value plus 2 times this value, because these two are equal and these two are equal. So this comes out to be 0.0102 kg times meter square. Now we can find the torque. So torque will be equal to, let's just use the equation directly from here. Where is that? So here. So that's IAB times sine phi. So this comes from, because there is a cross product. And here phi is 90 degrees. So sine phi becomes 1. And we just have torque equals to I times area times B. So that's 2 ampere. The current area is 0.5 times 0.5 meter times 1 meter, and the magnetic field is 3 Tesla, and we get the torque, the magnitude of torque, to be 3.00 Newton per meter. Now we can use this equation over here. So this is the total torque we found, because the rest of the torques are basically zero. Like the torque about A1 is basically zero. So we are summing up the torque for it. Now we use this equation. So alpha then will be equal to torque that we calculated over here over the moment of inertia that we found here. And we get that value to be 290 radian per second square. But note that this angular acceleration will keep on changing or will not continue, because the torque changes as the coil starts to turn or the coil starts turning. So after that, this will also change.